Good morning, everyone. Now, today we'll see the implementations of code converter on digital kits. We already performed the binary to gray code assignments with the help of virtual lab. Now we'll see the actual implementations on the digital trainer kits. We already studied the concept of code converter, how to design the truth table, how to apply the logic for calculating the reduce equation. So the first part in code converter is binary to gray code converter. So the circuit diagram for the binary to gray code converter is this one. We already calculated the equations for binary to gray code, and from that equations we have designed this circuit diagram. Now this circuit diagram we are going to implement on digital trainer kits. Now observe first in this circuit diagram, uh, the logic gates, required logic gates is nothing but your XOR gates. Now if you observe in this circuit diagram, there are only 3 XOR gates. So the IC 7486, on that particular IC there are 4 XOR gates are there. So out of 4 we need to use only 3 XOR gates. So here we require only one IC, that is 7486. Now here I have mounted the 7486 IC. Now first thing is you have to connect the VCC and ground for this IC. So consider first 14 number pin, so 7 pin on left side and 7 pins on right side. So first pin, this is a first pin and this is a last pin. Last pin is nothing but 14 number, so it should be connected to the VCC. Then connect ground, so this is 7 number pin, so it should be connected to the ground. So here the ground section is given, so you can easily connect to the ground. Now first thing is, as per your circuit diagram, if you see, so B3, total 4 inputs we required, will get a 4 output bits. So for B3 directly you can connect to the G3. Then first XOR gates, we already mentioned this pin number. So first and second inputs are B3 B2, and at pin number 3 you are getting the G2 value. So first we are implementing G3, directly we are connecting B3 to G3, and then we are implementing by using first gate of XOR gates, we are implementing the G2 value. So any 4 inputs you can consider from this one. So I am considering this is my B3, then I am directly connecting to the output section. This is my now G3, because B3 is equal to G3. Now I am implementing the first XOR gate. So first pin on first XOR gate is nothing but B3. So this is my B3, so I am connecting to the first pin. Then to the second pin I am taking second input, that is B2. Always consider your input in sequence: B3, B2, B1 and B0. MSB left side, LSB right side. So first gate is implemented. The output of this first XOR gate, it is nothing but coming from your pin number 3, and it should be connected to the second output pin. So here B3, now this is B2, sorry, G3, and this is G2. Now we want to implement the next XOR gates. So for next XOR gate, 4 number pin is again coming from the B2, and 5th number pin is nothing but your new input, that is B1, and at 6th number pin you are getting the G1. So here you can consider the multiple connections for your B2. So it is connected, it should be connected to the pin number 4. At pin number 5, next input, that is B1. Now I am considering this is B1, it should be connected to pin number 5. pin number 5, and at pin number 6 you are getting your next output, that is nothing but your G1. So it should be connected to the output section. So this is my G1, G3, G2 and G1. Now remaining one is your G0. For G0, if you check circuit diagram, 9 and 10 are the inputs, and at pin number 8 you are getting a G0. So for 10 number pin you require the new input, that is B0, and at pin number 9 you are getting the multiple connections from the B1. So this is already B1, so I am connecting to the pin number 9. So this is one is 8, this is your 9 number pin. Now at pin number 10 you have to consider the new input, that is B0, and it should be connected to pin number 10. Then at pin number 8 you are getting the output, so this is your pin number 8, so you are getting the output. So connect it into a output section. Now these are my 4 outputs, B3, G3, G2, G1 and G0. These are my 4 inputs, B3, B2, B1 and B0. Now we'll check the output part. So for output purpose you should have the truth table. You need to verify the truth table. So here if you consider the truth table, so here now we'll check only for some entries. Now I am going to check these entries. First entries for 0 0 your output should be 0 0. Then for 0 0 1 0 your output should be a 0 0 1 1. Then I am going to check 1 0 1 0. For 1 0 1 0 your output should be all high, and for all high your output should be 1 0 0 0. So I am going to check only these combinations. You can verify all the combinations, no problem. Now first thing is I have kept my all input to the 0 bit. Okay, all these inputs are at a 0th position, so my output is, all output bits are 0. Now I am changing the input 0 0 1. Now here you can observe 0 0 0 1. So this is a required gray code for the binary. Now I am changing the input 0 0 1 0. If you change the input 0 0 1 0, your expected output is, as per truth table, 0 0 1 1. See here both LEDs are blink, so we can say 0 0 1 1. Now we can check the input 1 0 1 0. Now in that case we require all LEDs should be blink. Now here you can observe all LEDs are, see here, are high. Now we can check all inputs are high. As per truth table your expected output is 1 0 0 0. Now only first LED is blinking now or high, and remaining 3 LEDs are 0. So in this way you can verify all the combinations, input combinations in a given truth table for binary to gray code conversion. Now we'll see the next part, that is gray to binary code conversion. Now here this is a circuit diagram for the gray to binary code converter. Now you can observe here again in this circuit diagram only the XOR gate is used. So 3 XOR gates, 3 number of XOR gates. So again we required only one IC, that is 7486. Now in this particular circuit, so output of your first is G3 is equal to B3. Now your input part is gray code and you have to check the binary sequence. So here G3 is equal to B3, similar in previous case also. Then output of first gate, it is connected to the output section. Again the same cable should be considered as a one of the input for the next XOR gates. So in this way we want to implement gray to binary code converter. So here I have considered the same IC 7486. Now first step is same, you have to connect the ground and the VCC. So first connect VCC. This is my VCC. Then at 7 number pin connect the ground. Then as per circuit diagram you can say that G3 is equal to B3. So I am considering this is G3 as a input and B3 is a output. So I am considering this is my output. Now next thing is first XOR gate. So for first XOR gate, what are the inputs? G3 and G2 input. You are getting at pin number 3 you are getting the B2 input, and pin number 3 is again the input for the fourth number pin. So implement B2. So by using multiple connections, G3 connected to the first pin, consider second input G2, this is my G2 connected to this pin number second, and then at pin number 3 you are getting the output, that is B2. Here you are getting the output B2. Now you have to connect same pin number 3 as the input to the pin number 4. By using multiple connections you can connect to the pin number 4, and at pin number 5 as per circuit diagram we require a next input, that is nothing but your G1, G3, G2 and this G1. Now at pin number 6 you are getting the output, that is your B1. Now as per your circuit diagram you can observe 6 number pin should be connected to the pin number 9, and at pin number 10 you connect a next input, that is G0. So at pin number 8 you will get a B0 value. So connect 6 number pin to the pin number 9, this is 8 and this one is 9. At pin number 10 you have to connect the next input, so this is my next input, okay, and connect to the pin number 10. At pin number 8 you are getting the last output bit, that is your B0. Now the connections are over. Now we need to verify the truth table. So for truth table the expected output is, suppose I am considering all 0 0 0. So for first case required bits are 0 0 0. Now if I am considering the 0 0 1 1, that is a gray code sequence, so you will get a 0 0 1 0. Now when I am applying the triple 1 0 1 0, in that case when you are applying the 1 0 1 0 your answer should be this one. Okay, so in this way you can apply the number of inputs. So for 1 0 1 0 the 1 1 0 0 expected, and for all high values if you consider, so the expected output is 1 0 1 0. Now we'll check it. So first inputs are 0 0 0, output is 0 0 0, expected output is 0 0 0. Now consider connect it properly. Now consider the 0 0 1 1. So if you are applying the 0 0 1 1, your expected output is 0 0 1 0. So here if I am applying 1 1, so your expected output is 0 0 1 0. Now I am applying all our high inputs, G3, G2, G1 and G0, all are high. So your expected output is 1 0 1 0. Now if you consider 1 0 1 0 as an input, so your output is 1 1 0 0. In this way you can apply all the combinations of your as an input gray code, you will get the required or the expected output. So in this way you can perform the binary to gray code and gray code to binary conversion with the help of digital trainer kits. Thank you.